SQL was never intended to be used by computer programs. It was a console language for printing reports. Embedding it into programs was one of the gravest errors of our industry. Normally, I don't talk much about Uncle Bob's takes on this channel. We are not super aligned overall. But I have a few reasons I want to cover this today. One is that I don't actually think this take is that bad, and there's a lot of good we can learn from it. The other reason is because it is a reply to me. I accidentally started Bob on an unhinged anti-SQL tangent that he has since filmed multiple weird videos about that we need to cover because, again, there's a lot that we can learn here and benefit from here, but it's also utter chaos, and I want to do my best to break it down. So we're going to go over the origins of his take here, where they came from, and what I think is good about it. But someone's going to have to cover the cost of moving off SQL, so let's hear from today's sponsor really quick first. Today's sponsor is a company that Figma is petrified of. Yes, the one and only Lovable. I'm so thankful to have these guys sponsoring me because they built an awesome product. They're one of the few app builders that really gets us as developers. They're not going to just make this magic environment in the cloud you have no access to. See that? That's a GitHub button because everything you do is synced with a real GitHub repo, so you can pull it down on your machine and do it however you want. You can also just turn on the code button so you can see it in here as well if you so desire. This is a job board that I had it generate for me, and it's stunning. Like, this is actually already usable in its current state. I'm impressed this was a one-shot too. And once you want to set up things like auth and backend, there's a one-click connect to Supabase button. But this isn't the Lovable you already know and love, because this is Lovable 2.0. Yes, they just shipped a huge set of changes, including multiplayer, agentic chat mode, and everyone's favorite thing in AI apps, security scan. So it's going to be way harder to make an insecure app, as we've all probably seen from these vibe-coded apps that are floating all over the place now. And of course, the thing that has Figma so upset, dev mode. And if you don't feel like writing the code yourself, you can just click this little edit button, click the thing in the UI you want to change it, hit save, and it will update the code for you. You could also click an area and tell it to do a specific thing to it, and it will do that as well. That level of granularity is still unbelievable to me. It's a very new thing. Most of the sites like this don't have that, and the results speak for themselves. You can make beautiful stuff with this, and you can take my word for it, or go to the homepage and look through the hundreds of beautiful things people have already made with it. It's a legit way to make awesome stuff, and if you don't feel like figuring out all the front-end things yourself, here you go. If you want to build something that's truly lovable, check them out today at soydev.link/lovable. Also, my apologies. I didn't have a bathrobe. That's why I didn't wear one. Let's go into how we ended up here in the first place. I was recommended this particular talk by Uncle Bob, which concerned me because normally him and I are not very aligned. And somebody was saying that we were very similar, and I was confused. Normally, Uncle Bob and my takes don't overlap a whole lot. I think clean code has done irreversible damage to the software dev ecosystem, and the practices it calls clean often obfuscate bugs with the assumption that if you make your architecture perfect, there will be no bugs. Reality is that there will be bugs. Making it easier to find and identify them is much more important. So not a fan of that. Also not a fan of whoever the fuck was managing the camera for this and not putting his slides in. You cannot see the slides at any point during this video. It's chaos. Anyways, I'm skipping to the database section of this talk because that's how we got here.
Anybody out there write SQL? Who writes SQL? I'm sorry. It's a shame that you have to write SQL. SQL is a fine language if you are sitting at a console and you want to query a database. It is not a good programming interface. It possibly is the worst possible programming interface because programmers don't want to pass strings into an API. They want to call functions into an API. And wouldn't it be nice if all of our databases had an actual API that we could call functions on instead of trying to construct horrible select where strings that fits some nasty syntax? And so what do? We make our ORMs. We get the whole problem away from us. We use ORMs. Where's the ORM in this?
It'd be really nice if we could see the diagram, but yeah, you get the point. He thinks SQL is bad, and you would imagine, okay, so he prefers ORMs because you get a nice separated abstraction. Well, he doesn't. Are you happy with ORMs? Ew. What would be an alternative? An API. But wouldn't the API just end up issuing SQL under the hood? Unless we invent a new query protocol, we're just wrapping the same thing in HTTP. Run away, run away. At least he recognizes that his take is basically impossible to defend, but it is a valid core point he is making here. And I want to do my best to break down the layers here, because there are things that are right, things that are wrong, and things that are in between. So let's break down the parts to our best ability. We have SQL is good for data terminals or consoles or whatever. SQL is bad for developers, in particular in applications. ORMs are bad too. Everything should be an abstraction with simple inputs and outputs, and databases should just be an API that expose the data I/O. This is roughly the core points he makes when he talks about this, and I want to go through these. I also realized I never gave context on who Bob Martin is. Robert Martin was one of the key signers and influential people in the Agile Manifesto, helped invent the solid principles, and also huge OOP guy and big on test-driven development, the clean code patterns that he helped key and create. What's funny is he has a book on C#. He hates C#. He shits all over it now. He seems to be a Go fan at the moment from what I got from his most recent talks. But he's also a big OOP guy, even though he likes purity in pipelines. He confuses me. And there are a lot of flaws in the way of thinking from clean code. But also he makes good points here and there. And this is one of those times where I think there's a lot of value in the take. Let's watch his bathrobe rant he posted this morning as a follow-up to the reply to my tweet.
What is it that you think happens inside of a SQL database when it receives a SQL string? Well, it compiles it down into an internal representation, a data representation, and then uses a set of function calls to interpret that data representation to access the data, period. And that data representation and those function calls are what we programmers should be using to access data. We should not be using some bloated old arcane syntax invented 50 years ago for people typing at a teletype.
Love the teletype reference. Different era. Worth noting, he is 72 years old and replies to my tweets with Shrek memes, but you get the point. The reality is that the layers get more complex as you understand them better. I was trying to prompt for this earlier. So let's use the new quote feature on T3 chat. I'm going to grab this. Let's make a new chat with this. What would the function calls inside of SQLite look like for this SQL query? Show examples of the internal SQLite code that would be called when this query is fired. I asked 2.5 Pro, which should be an interesting response. I'll also ask for 04 Mini, because it's a recent favorite model. I'll leave it on medium, that's fine. Here we go. Here's Gemini 2.5 Pro's response. Let's break down what happens internally with SQLite C library. The process generally follows these phases after the C API call. SQLite 3 prepare, SQLite 3 step. SQL is tokenized and parsed into an internal representation, a parse tree. The parse tree is analyzed to ensure the table and column names are valid, data types are compatible, etc. Query planning and optimization. SQL decides the most efficient way to execute the query. For where ID equals 42, it would strongly prefer to use an index on ID if one exists. If not, it will plan a full table scan. CodeGen. The query plan is translated into a sequence of bytecode instructions for SQLite's virtual database engine. And then the VDB executes that bytecode, interacting with the B-tree storage engine to fetch data. You could say that SQL is the original AI, where you write a SQL query and it turns that into the right bytecode to get your data. I'm half joking, but you get the idea though. SQL is meant to be a standard syntax that query engines and planners can take to generate the most optimal path to get the data you're asking for. Is it the ideal language for this? Almost certainly not. Would it be nice if it had better primitives for managing schemas and type safety and integrating it into our applications? Absolutely. Would it be great if row-level security was implemented everywhere? Absolutely not. But the key to understand with where we're at now is that the complexity of how these databases are implemented is great enough that to live without it means to live with things that are much worse overall. Is SQL the original ORM? You're going to hurt my head. Here's some examples of internal C functions that might be involved during the stages that you specify. So here's the select. SQLite 3 run parser would be the main entry point. SQLite 3 get token breaks down the tokens. Analyze in planning. SQLite 3 select this is actually a function inside of SQLite codebase. There's a mirror here. Cool. Let's scan this mirror. I want to make sure we're not hallucinating too hard. Okay, there is a SQLite 3 select function. Cool. It's not totally hallucinating. Apparently this function is thousands upon thousands of lines long, though. That's hilarious. Yeah, cool. So we're not in total hallucination land. That's good to check. But if you notice here, there are a lot of steps that it is going through in order to turn that very simple query, which was select ID and name from user where ID is 42. The amount of steps to call those internal functions is absurd. And I know this isn't fully Bob's take, but it is in the lines of, instead of SQL being the interface on top of all of this, we should do all of this ourselves in our applications, but build it with an abstraction that has the right function calls. So we would have like database.getUser by ID, pass it the ID, and it would return it and do the right things underneath like this without the SQL part. Let's ask about Postgres, something people actually like. I know y'all don't like my love of MySQL. Where's my thinking data, 04? Okay, it's like 50% if it gives you the thinking data now. It's been quite annoying about that, but at least we get the response here. PostgreSQL main function will eventually call exec simple query. Hopefully you're seeing that this is not fun. Writing this stuff is not fun at all. So I have my hesitations on the whole we should write the thing that hits the system directly bit. I also don't think that exposing that API is particularly sensical. But we need to go a bit more here. The benefits of SQL. Because there are a lot of things SQL did really well that have kind of resulted in its success. And I think understanding them will help a lot as we digest the failure parts. Biggest one is it's standardized, mostly. So it's not too hard to switch between like SQLite, Postgres, MySQL, Cassandra, and all these other SQL-like syntaxes. It's pretty standard, and it's allowed for us to build tools that work with lots of different implementations. On top of that, it's allowed for crazy optimization between that SQL layer and the rest of your database. If we have our app, and our app code connects with SQL code, and then that SQL code accesses the actual DB implementation. The cool thing about SQL as a standard is the freedom it's given us as an industry to fuck around here. We've been able to see and do crazy things, like all the work that companies like PlanetScale and the Vitesse team put in to sharding for MySQL in order to change how this code actually splits the data across many different boxes to make it as performant as possible. You can have crazy functionality added at the database layer, like row-level security or a WebSocket layer put in between, so when the SQL code hits, you can send updates to other clients. SQL as a standard syntax to access our data has allowed us to do crazy things, not just here between the DB and SQL, but also here between our app code and the SQL with ORMs and other innovations in that layer. Both of these things are really cool. And I know Bob's like the big abstractions guy. I think he's overthinking the abstraction point in terms of a given application. But if you think of this not as our app, but our apps as an industry, these abstractions have allowed for industry-wide innovation to occur in ways that are really, really cool. That said, there's a thing I have talked about a lot. I had this with a special command in my Twitch chat. GraphQL goes here between the server and the user, not here between the server and the database. GraphQL is a way to query an API meant to be an alternative to standard like REST fetching to allow for graphed data to go through your application more easily. So if you have a user object, the user has friends, the friends is a list of friend objects that are users that have their own nested properties you could select from too. It's a way to select the right things nested in your application code. And GraphQL is really cool for certain things at certain scales. It is not really cool for a lot of the things I've seen people use it for, in particular, throwing it in between the database and the server, or worse, between the database and the user without a traditional server. Oh, no. GraphQL is not the solution to any of the things we're talking about here. But due to the nature of SQL, we could put something like GraphQL here between the SQL and the DB, realize it's wrong, and throw it away. And that's why this abstraction has historically served us well, and why SQL has been as successful as it has been for what, like 50 plus years? 1970s, yeah, 50 plus fucking years. Kind of crazy. So this abstraction has allowed for a lot of innovation. His view is, instead of SQL being here, DB manager service actor, you build an abstraction here with functions and methods on it that will call the deep details of the database. But now that layer is gone, because now this class is heavily reliant on the DB implementation details. He claims you should be able to just swap this out with another. That's not how this works. This class is going to inherently be super painfully tied to the implementation on the database layer. And as a person who likes abstraction, I'm a little confused about why he doesn't like SQL as that abstraction layer, beyond not liking the syntax. He does have a blog post where he goes a little more in detail. This is Bobby Table's blog post. If you're not familiar with Bobby Tables, it's a classic KCD comic. I think about this one way too much. Hi, this is your son's school. We're having some computer trouble. Oh dear, did he break something? In a way. Did you really name your son Robert Drop Table Students? Oh yes, little Bobby Tables, we call him. We've lost this year's student records. I hope you're happy. And I hope you learn to sanitize your database inputs. A classic. He has a blog post about this, 2017, which in terms of both when this XKCD came out, October 10th, 2007. So this blog post is over 10 years later, and it still feels old because 2017 was 8 years ago. You get the idea. Anyways, SQL is daemon spawn, and no self-respecting software dev should ever use it. Okay, that's a little hyperbolic. Demons did not create SQL. Indeed, the folks who created it were filled with nothing but good intentions. But you know what they say about the road to hell. I want you to think about just what a supremely bad idea it is to use a textual data access language. Such a language can pass through the user interface of a system and provide unauthorized access to all the data contained within. Wait till he learns about how rendering HTML works in the browser. Now, of course, we all know that we are supposed to scan all our inputs for potential SQL injections, SQLi attacks. And yet, hundreds of thousands, if not millions of users have had their data stolen by just this mechanism. Why? Because it's unreasonable to expect that every single user input of every single system is going to have the protections that are required. The problem, of course, could have been eliminated at the source decades ago. Back in 98, rain.forest.puppy described in Frac how to slip SQL statements through a user interface to execute them. The instant that article was published, every single programmer in the world should have ceased to use SQL on the spot. I find it absolutely amazing that SQL is still used. Did we learn nothing from Equifax or Yahoo or, well, I mean, just about everybody at this point, hasn't it? And here we are, comforting ourselves that our current frameworks will handle the issue. Hibernate will handle the issue. JPF will handle the issue. Rails will handle the issue. I'm not going to say that I want to be demonetized. Frameworks don't handle the issue. Programmers do. And programmers haven't been handling the issue all that well, have they? Here's an idea. Stop using SQL. SQL is the ultimate security breach. SQL is a portable, universal, textual language that can be transmitted through the user interface of a system and, if passed to the SQL engine, can provide absolute access and control to all the data in the system. The very idea that SQL statements might come in through the user interface and be held in RAM ought to fill you with unmitigated terror. All it takes for some poor idiot programmer to fail to remember the exact arcane gesture that offers the appropriate protections. Can you tell which of these statements is vulnerable to a SQLi attack? The language is Ruby, the framework is Rails. User.where email is email, parents, email, passing this in. User.where email : email, or email equals question mark, or email equals : email. Because this passes it in as a string unsafely. This passes it in as a variable where it will actually be parsed and sanitized properly. It is kind of funny because this isn't a problem with SQL syntax. This is a problem with how unclear the unsafe path is in Ruby. But I get the point of like the ORMs are not doing a good enough job of protecting us. SQL under the hood is the thing that is vulnerable. But it's not just SQL. Like this blog post is on a page written with HTML. Does it have a comment section? I don't think it does. I don't think he accepts user input. But a lot of websites do. So if I have this HTML page and we have on it a paragraph, user submitted content. And in here, we want the user's submitted content to render. What happens if the user submitted content is something that we don't actually want? Like if the user submitted content is sup nerds, whatever, that'll render fine. But what if it's LOL, close P, script, reopen the P tag. Now, if you didn't sanitize your HTML rendering properly, and this user input is just blindly rendered here, you have a huge problem because you let the user close the P tag, open a script tag, and do some stuff. It's not that bad if they're just alerting, but it gets a lot worse if you give it a source for some cross-site scripting bullshit. This is a mistake that is so easy to do. And the response to this problem isn't, well, HTML sucks and we should never use it. It's, we need to be considerate of how the HTML is put into the browser. And we should be. Frameworks like React handle this by default for us now. And if you want to actually directly set HTML values outside of passing them as properties where they're sanitized, this is how you would enable this type of bug in your application if you were to do this yourself. The risk here is very real. It's not the same like you have access to the whole database thing, but in some ways it's worse because if I leave a comment on a blog and the comment links to like example.com/my hostile JS script, now whenever somebody loads that page, as long as the comment is rendered, this script will now run and I can execute anything that normally I wouldn't be able to. Like, for example, if you have cookies on the page that are HTTP only cookies, JavaScript can't access those cookies because they're HTTP only. But if I get JS running on your page, I can fire API calls with access to those cookies. So I can take over your account. I can trigger a reset. I can trigger an email address change if those are APIs that I hit with those cookies, simply by leaving a comment with this formatting. What's even worse is I could add something to the script tag that hides this element so no one will ever even see it. It just quietly runs in the background. The problem with user inputs is you don't control them. And the way Bob likes to think about systems is assuming control over everything. And this has problems in more places than here. I found this awesome video yesterday on Internet of Bugs channel, which I forgot the sub to, so I'm fixing that now. And there was a really good example in here of the painful points of clean code.
So imagine a hypothetical expense report app. So imagine you get a bug ticket that the user submitted receipts totaling $25.13, but the report only said $25 even. So where did the extra 13 cents go? So I've had a variant of this problem. It wasn't exactly this, it wasn't expense reports, but it was the same kind of thing where the amount ended up being wrong because of something that you'll find out about in a minute. So for purposes of this discussion though, I'm going to talk about it as if it was expense reports, but this is more or less an actual problem that I've run into in real life. So I'm looking for why it is that this stuff that I can see added up to $25.13 didn't end up saying $25.13 and where the hell the other 13 cents go. And I look for places that the cents get cut off. I look for places that things get rounded. I can't find any of that. I have no idea what's going on. It takes me days off and on fighting with this. I still have no real idea. And then what happens is I'm looking at the specs and I'm looking at the accounting manual and I realize that city day in question, the per diem for that was $25. Turned out that the issue wasn't that the $25.13 was getting truncated to $25. It's the $25.13 was being ignored completely because the system had decided that those receipts weren't relevant because that person was supposed to be on per diem that day. And in this particular case, the conditions by which the program decided, is this a per diem kind of expense report or a look at the receipts from the restaurants kind of expense report, was wrong. In that particular set of circumstances, it made the wrong choice because of weird accounting reasons. This is a particularly egregious kind of bug. And it's specifically caused by the technique on page 109 and 110 of Clean Code. I will put those on the screen.
What a baller move, by the way, to say this is bad for these reasons, and it is discussed on this particular page of the book. The normal flow. I could explain it myself, but honestly, Internet of Bugs does such a good job, I'm going to let him do it.
What this does is it tells you that you should return an amount that's either the per diem amount or it's the total of the receipts amount, and not tell anywhere else in the program which one you picked. You're explicitly told by Clean Code at this point to hide why you made that decision from the rest of the program. And this is under the guise of error handling. It makes me furious. They're telling you that the right way to handle a potential error is to take information that might be relevant to finding a bug and prevent anywhere else in the code from having access to that information because it's hidden inside the private part of this class. But it breaks the basic fundamental stuff over here shouldn't be affected by stuff over there thing, because it draws a line between over here and over there, and it hides all of this stuff in these private classes and doesn't let anybody else in the rest of the program see any of that information. This is an utter failure of the philosophy that goes into clean code, and honestly, most of the programming advice that you see. It assumes that you can make code cleaner by simplifying things, and that's just wrong, because that assumption is only valid in a world where the code you're simplifying is 100% guaranteed to be 100% correct for all time, and it's not. Even if you have 100% test coverage, and they did, more or less, in the case that I ran into, that doesn't mean you understood the requirements. That doesn't mean the requirements haven't changed. It just means that the code you wrote matches the understanding that you had at the time. And in this case, as with a ton of cases, there was a corner case. There was a set of circumstances under which the original programmer's understanding was wrong. Maybe even the initial specification was wrong. It took a while for that to get triggered and noticed.
This whole video is phenomenal. I don't want to just sit here and watch the whole thing. The link will be in the description if you want to check it out yourself. Highly recommend. Yeah, Internet of Bugs here killed it and made a lot of really, really important points. Specifically, this idea of bugs aren't avoidable. We should build our systems to make it easy to find and fix them, not to abstract them out of existence. The world doesn't work that way. And honestly, I feel the same way here in terms of the SQL attack argument. Like, we have solved this problem. SQL's been around for 50 years. We have way too many ways to sanitize our inputs now, to the point where it causes its own problems. Adam tweeted a while back, when server actions were first being presented at NextConf, this example was given where we have a use server call in a form action that awaits SQL insert into bookmarks slug values slug. This looks super dangerous because I could just inject whatever I want there. Well, guess what? This isn't just passing a string. Notice there's no function wrapper on the sides. This is a template literal, which means it's a function call that works by passing first a string, which is whatever this part is, but it will segment out these sections. And the rest is an arguments array. So it's a function that is being called with the first string and then all of the arguments. So you have your own code that will map those together and sanitize the inputs. So we have this thing that looks like a traditional SQL call, but is actually totally fine and safe. Everybody in the replies here was freaking out over the security issues. And it's become a consistent meme since, where like multiple years later, he's still posting it and it still gets a ton of attention. He knows it's escaped and this is fine, but it's funny that this like forever will plague poor Sam's, like, yeah, you get the idea. People are almost too scared of SQL injections. So personally, we go back to here, to the things he said. I'm going to add in one, which is SQL is a huge risk. People don't sanitize well enough. I'm going to just cross this one out because it is a mostly solved problem, and I don't think it's necessary in our arguments against SQL. It almost feels like a crutch he leaned on back then. And it's also notable that he didn't bring up the SQL attack angle at all in his recent tirades against SQL. This seems to be an older take that I don't know if he would defend right now, because I feel like we've, as an industry, largely solved this problem. As long as you're not writing and firing raw SQL queries just as strings with user intent injected in them, you're much more likely to have an XSS exploit than you are to have this, almost certainly. And those types of exploits are much easier to run into in a properly clean code architected system because you don't know whether or not something's sanitized before you get it. It's a mess. So I said I wanted to agree with him here because there's a lot of good stuff. So now that we've axed that one point, where are my agreements? Well, first and foremost, we have this guy. SQL's good for data terminals. I know a lot of like crazy data people just from like my past, and some of those people can do incredible things with SQL. And the fact that I can have an ORM layer that lets me write data to a database in a syntax that makes sense to me as a developer, and then the data team can go into the same database and fire these crazy queries and mode analytics and shit, is awesome. It's actually really cool that we have a layer that allows for the data team in their terminals, in their consoles, in their mode analytics tools to access that data and for me to write it with a different syntax that compiles to the same syntax, it's a huge win. And it has let me see how good SQL is for those crazy nested relational queries that people often have to fire when they're trying to find certain characteristics about users. So I agree here for sure. This, green for agree. SQL is bad for developers. This is where things are a bit iffier. But honestly, I've slowly come around to this point, not necessarily for the same reasons. Do you know what I don't like about this syntax? Imagine if instead of an insert, it was a select. What I don't like is that the result of this call will always have to be typed as any or unknown because we don't know from the string what's in the database. This is what makes something like Drizzle so cool. Drizzle's an ORM, in quotes. It's closer to a query builder in a lot of ways for TypeScript developers. And if you look at the syntax, so I don't even know if they have any on the homepage, but they do have this section. I hate Drizzle. Sorry, Drizzle, you suck. I love their callouts here. And what they built is a very SQL-like syntax, db.select from countries, left join where these values are true. If you look at the schema, it's in TypeScript, which means the type inference can all be done via the TypeScript definitions of your schema. And then you can use their CLI to generate SQL code to fire the migrations. I will say migrations are such a terrible fucking abstraction that they in and of themselves kind of make the argument for why application code shouldn't use SQL, because your application state should be represented by the code and the data in the database, not the shape of the database that you then have to synchronize between the application code and that database code. Ideally, that synchronization step isn't necessary, and we don't need this migration primitive in order to keep things in sync between the two. It's one of those abstractions that just feels like it shows these things weren't built to work together. You can see the query this writes for you under the hood, because this compiles to pretty standard, boring vanilla SQL, but we also get the type safety guarantees, and when we pass inputs to it, it will sanitize them for us too. So this is what I like about Drizzle. It lets you write SQL in TypeScript with type safety. So it feels much more part of our system and our application. The relationship between our application code, our type system, and our database is much more cleanly attached. And what I like this for is something that Bob would probably hate. If I go into the schema and I change this from name to full name or to username, I'm not going to get a type error in the API that selects star and passes it to the user. I get the type error in the component where I try to render it, because the types are honored from the place they are defined in the database to the component where they're being rendered. So if I'm rendering user.name and I change this field in the backend, I get a type error where I'm rendering it, which is so nice. To go back here, I agree that writing raw SQL in your applications is bad. I'd even go as far as to say things that are less raw but don't give you that relationship between the structure of the data and the actual application code are also just as bad. You need a solution that bridges that gap in order to get the benefits of SQL. I'm neutral on this because I don't think SQL is bad because of the security implications or things, but I don't think you should write SQL code directly in your applications. And migrations are a weird abstraction. Like, we have the history of our state and our Git history. We don't need it in the migration files too. And now the first take I fully disagree with. ORMs are bad. I wish he would go more in detail on this, but it seems like he thinks, we go back to the diagram here, if our app isn't hitting SQL code directly, it's hitting an ORM, and then the ORM is hitting SQL instead. His argument is that the ORM is unnecessary here, and instead, it should just hit the database implementation directly, and SQL is a useless in-between language here. I don't agree, because what happens if we have multiple apps? I'll say user app. But what if I also have our data analytics? What if I also have, I don't know, our on-call dashboard? If we don't have this SQL layer in between as a syntax, either all of these have to go through our ORM layer, which is obnoxious because the data analytics team doesn't want to use the same programming language that the application development team does, and they shouldn't have to. The analytics team should be able to do what they prefer. The on-call dashboard should be as easy as possible to fucking maintain and not be too directly tied to the implementation details here. Because if the on-call person is dealing with an outage in the package that manages your data, they can't get any of the information. So like all of these going through here doesn't make sense, which is why right now they don't. What happens looks a lot more like this, where these different layers will hit the SQL, and the ORM is just the abstraction that one or multiple different layers might use to access the SQL. But since we all have the SQL layer, different places can access the data. And if all of these had to implement those terrible calls that we saw earlier, like if they had to write all this code to fetch the data, no, we know better. We've learned this lesson. If every team is writing their own assembly to access something, then you end up with a bunch of weird locks and terrible performance. You don't end up with better code. This does not work. This makes no sense at all. Are there bad ORMs? Yeah, absolutely. I'd even go as far as saying most ORMs are pretty bad. Active Record changed the way that application developers think about data in a very positive way, and I don't want to talk shit on it for that reason. But it does have a lot of the issues like what we saw in the blog that Uncle Bob did that showcase why it's not a big enough abstraction to prevent you from these, in my opinion, very preventable mistakes. So I disagree with him here, and I wish he would explain more in detail what he doesn't like about ORMs beyond the like abstraction layer bit there, because I think that SQL as a primitive that we use does make a lot of sense. The same way that languages that compile to C make sense. Next, everything should be an abstraction with simple inputs and outputs. I'm going to break this into two. Everything should be an abstraction. No. Simple inputs and outputs? Yes. I love my functional programming stuff. And the way he has been framing this, especially recently in his recent talks, I almost feel like he's starting to fall down the functional programming pipeline a little bit, which is exciting. But the point here is that your database access layer shouldn't be an application-specific abstraction until it makes sense to. A pattern I've liked doing recently is I make a DB object, and I have a query key and a mutation key in it. And now whenever I want to call something, I call db.query. And here we have db.query.getImages with tags, or db.mutate, delete user data, reset usage, update subscription. And now this is all type safe too, because it's all calling these drizzle calls directly. But this is SQL, so to speak. I'm writing this in a way that's very SQL-y. And there are cursed things in here as a result, because SQL far from perfect. We look at the get images with tags code up here. Yeah, get images with tags. I do some weird shit where I'm internally joining, because this is a flaw of SQLite and how bad the relations are. I do not get the hype around SQLite. Every time I try to do anything meaningfully relational in it, the whole model starts to fall apart for me. But here I'm trying to get the tags that an image has, and I have to JSON group them in order to get this in a reasonable fashion. It's obnoxious. But the point here being, I can write SQL and get a type safe result, and then have to parse this one inlined bit here. Thankfully, none of this is taking a user input, but if it was, I'd have to pass it as an argument in order to keep it safe. You get, oh no, this is templated, this is safe. I can pass user info here and it will be safe anyways. Regardless, annoying. That said, the idea of a object that defines all the ways we interface with the database, that's a fine idea. And I like that abstraction. I don't always like that abstraction, but when it does make sense for the application, so we have a standard way of accessing data, cool. But should that be the database layer, or should it be a level higher or lower? Great question. I don't want to tell you, because all of us should have our own decisions that we make about these types of things. There's a lot of different options and a lot of different ways to structure our stuff. If we prescribe one single way, we are setting up a significant number of people for failure because it won't make the most sense for them. We should try to keep things as simple as reasonably possible and add complexity where we have to solve complex problems. Building our own database access layer that calls internal functions in a data pipeline is not the simple way. It just isn't. Back to Bob's takes here. Databases should just be an API that exposes the data I/O. No, I don't agree here. I think that databases should have better APIs, absolutely, and that SQL was built for a different era. And that's why Mongo got as popular as it did. But the I/O inner workings for these things is insane. Like, the abstraction of the ORM has allowed for the database to do crazy innovations and changes. Like, I was able to move from Redis to PlanetScale to a SQLite provider all in a few hours because of the abstraction of that ORM. We don't have a low enough level abstraction for the database such that we can make those changes. And the standard nature of SQL has made it a lot easier to swap between the things that aren't the first one I said, they're Redis. Redis to SQL was the big lift. But once we were in SQL land, switching between things was relatively easy. I like the idea of database technologies thinking more about how we interface with them in application land. And we're starting to see this more. There's companies like Gel, Postgres Unchained. Gel's awesome. It's originally known as EdgeDB, if you're familiar. They finally rebranded to something that makes more sense. What they built is a very different syntax. You don't have to use it, but I'd recommend it. Select movie, title, actors, name 5, limit 5, rating, and filter. This is such a nice way to write something that in SQL would be very annoying, and you can do it in TypeScript too using their TypeScript client. The goal here is to build things that are much more closely tied to how we interface with the stuff in our applications. The idea of a nested key that is a relation that you can apply a limit to is very application-y. It almost feels GraphQL-y in a way, but in the right sense, because this is a database built around this. I should also disclose I'm an advisor for Gel. I've been helping them out a bunch, so I do have equity, so take my takes there with a little bit of bias. Another one that you should assume bias for is Convex. I currently have no equity in them, and I really should change that because I've helped them a lot, and I'm really excited with what they're building. This is a different way of thinking about databases where the code is the abstraction, and it just lives in your code base. I'm in the middle of a port rewriting T3 chat's server-side code to be almost entirely convex-based for the data, and it's been awesome for it. I have my schema, which is TypeScript code. Threads are a table with thread IDs, title, create at, all these fields. You get the idea. I define indexes so I can look things up more quickly. And then I have the threads file here, which is a set of functions that I'm now exposed to be hit on client, on server, wherever else. Queries have optional inputs. I made my own auth query wrapper so that I can make sure the authentication primitives are included. And then I return await context.db, query threads with index, order, take 200. What's cool here is this runs in a transaction layer that they wrote themselves that will take all the await calls, flatten them into a single transaction, and then fire it once, which is super cool. And they're all built on top of MySQL at the moment, and it runs great. The performance is nuts. But since they built this abstraction, not only is it nice to work with, not only is it type safe, or if I do like use thread data, now when I hover over threads from Convex, I get all the type information here. I can also command click API threads get to go to this specific function, which is so nice. But since they have that abstraction, they also can build sync on top. So now I can connect via a WebSocket instead of a traditional HTTP call. And when a change happens to that data, it knows, because of the way the transaction layer works, what data isn't affected by a given mutation, and it can send the change to the user without them having to go refresh the page. Let's make a test thread understood ready. Cool, awesome. So I just made this new thread. Here's where the magic happens. If I hop over to my dev environment, go over to the data, and go to threads, and find that thread, test thread, right, cool. I'm going to change the name here to don't forget to sub. Now it's updated in the UI. I didn't refresh, I didn't trigger anything, just immediately updated. That abstraction is actually really nice because you no longer have to worry about traditional out of sync data problems that drive me mad normally. I've been very happy with this, and I'm so excited. It's going to simplify so many of the annoying things in our code base as a result. Like, because now on the server, I can fire a mutation that changes the title, and I don't have to worry about the client getting the update. I can just call the code on the server, and the client gets the update. This is an in-progress piece here, so ignore this. Theoretically, I would have validated this much earlier. I haven't yet. The part that matters is server convex client.mutation. I pass it the API internal chat update thread. This is an internal API, so you can't hit this. Only I can hit this via the server. Thread ID, validated thread ID, user ID, the user identifier, updated body, title. This is a mutation to the data through my application interface, my API, that on change, when this fires and succeeds, the client gets the update. I don't have to build my own thing that will refetch it. I don't have to send it down the stream like I currently do. I had to put so much work into this layer in the current implementation on T3 chat. It's insane. This create message function has been the bane of my existence for a while now. It's 618 lines. It is a couple different functions, but this file is where half the work for this fucking project goes. I have my stream helper that once we have synced up and gotten the state of things, fires this fetch call. This fetch call returns an SSE response because it's a post call where I'm sending events over time. So I'm streaming content back line by line. I then have to process the data stream. I was using my own implementation. I finally moved to the SDK from Vercel for processing the stream, but I had to write a lot of my own stuff here. And this is where all of the heavy parts are. On text part, I append and update the IndexedDB local instance. On reasoning part, I update the reasoning chunk instead. On data part, there's a lot of different conditions where data comes down. There's provider metadata, which I have to update the title for. There's rate limits, which I have to update other parts of the UI for. I'm not doing it right here anymore because rate limits work a little differently than they used to. We have the thread metadata, where I'm parsing to get the updated title out. We have image gen, which is a different data case because image gen goes down a different pipe than the text does, so I have to render this differently. Then the error case, where I do a lot of different shit. Because I have a separate error case, a separate finish part. All of this is for all the different cases that every chunk from the server can hit. If I could instead run all of this on the server and just hit the case, update the database, and the user sees the update, all of this can go away. I'm no longer trying my best to parse different cases with strings and hope that the value in the JSON I got back is correct. All of these abstractions that aren't safe between each other can be thrown away. And I just found a case with the error handling where I wasn't JSON parsing here, which meant the error message I was getting was wrong, and I was always hitting the catch case, which meant you would always render an error occurred instead of the actual error that occurred if the error happened during the stream phase instead of during the initial response phase. And just the fact that I have to think about all of this shit, first off, is why everybody's saying, oh, it's easy to build an app like this is just wrong. But more importantly, it's abstractions that I have to have because of the nature of the request shape that a better database abstraction can make just go away. So I very much agree in that sense that the way we think about databases right now does not map great to our actual implementation details of applications. But that's not because we need function calls that write data directly. I think we need a higher level abstraction. I think we need to go one layer up. And with that one layer up, all of a sudden we have way more functionality and control, and we can simplify things too. The last take of his, and he said this in the video, databases should not be the center of the universe. That's how he framed it. I fully hardcore disagree there. In fact, I think it's one of the better things we've done as an industry is the idea that we have our database, which is our state. The state goes through our logic, and then out of this comes the application. I am biased because I'm a functional programming bro. This is good. This is another way to write this is application equals function of data. This is good. This makes life much easier because if there is a bug that a user has, it's much easier to trace where the bug is. Is the database in a bad state? Okay, that's probably the source of the bug. Is the database in a good state and something else comes out on the application layer? Okay, let's walk back from where that logic starts on the application side and go back step by step until we're back at the database. Then we can figure out much more easily where things went wrong. And in large applications, this simplicity is phenomenal. I'm stealing this syntax to describe it from a certain community. This is how React is pitched. UI is a function of state. So if the state changes, rerun the function, new UI comes out. The way that Bob proposes we do this instead is quite different. Instead of database being the center and everything flows from it, the application is the center. But the application's a bit different now because the application has a bunch of different pieces. So your application might have all these parts and they're all in here abstracting away their different logic. And these can call each other in all sorts of different ways. And you can see how chaotic this gets very quickly. It's a bit of a mess. But this is clean because all of these services have their own abstraction. So onboarding controller doesn't have to care about how billing service works, but it does have to care that the user has paid their bill before contacting user management service to update things there. The worst part, though, is that the database still has to exist. And what ends up happening here is every single one of these things now has to contact the database. And you end up with absolute fucking chaos in the process. And don't say this doesn't actually happen. Every massive clean code architected code base I've ever seen ends up here. The point of database in the center of the universe isn't that it's in the center. I would highly recommend thinking of this less as like a 2D grid, and wherever you can, think of it as a one-dimensional path and process. If you reasonably can map your application to database, logic, app, where it flows through things top to bottom like this, everything becomes significantly easier to understand. Because when you have a bug here, you can trace the bug line by line backwards to where it occurred. When you have a bug here, tracing where it came from becomes hell. It's a murder mystery. It's not an actual debugging experience. This is not good. If you think of the world this way, putting the database in the middle instead of the app sounds so stupid. And what he is fighting against is the idea that database should be here amongst all of this chaos. And I agree in that regard. If you're in this chaos, the database being the center of it all, not good. But if you think less in clean and more in purity, and you think about how the database change can blow out everything below it, and the updated application state comes from database, goes through logic, app comes out, things get much easier. So if we take all these parts, move it here. Let's say the user checks out from something. User triggers checkout. The checkout would probably go to the billing service. The billing service might need to go update the user management service in this process. So billing service says, okay, this is new billing information. Let's throw it in the user management service so that we know that this changed. Then that will call the database. Awesome. Now, what comes out is the new application state. The database update combined with a refresh if you're not using something like Convex to handle this for you. Assuming we still have the same parts here, ideally it's just functions, not controllers and whatnot. The database change now results in the onboarding controller having a different state, and this will now render a different application state. Do you understand how much simpler it is to debug shit when your application is architected this way? Especially if this whole thing is framed as a function. This is why I like FP, because when you think this way, debugging instability and bugs become significantly easier. And the reality is the chain isn't actually this long. The chain is the user triggered checkout, billing service controller happened, user management service updates DB. What happens next is this part here is separate. So after the database change, you would trigger a refresh or something. So refresh, or the user just navigates to the page when it's done. Now, when we render the app, when a user navigates, so user opens page, they call a function effectively when the page gets opened. The function queries the database for the data it needs. It passes that data through the onboarding controller and whatever other layers are there, and then the application state comes out, and then the app comes out the other end. It's so much nicer when you think this way, but you need a clear input and output for everything. Like your entry point for a given URL on your site needs to have a clear function that gets called, that fetches data, passes that data to the right functions, one at a time in order, and then the result comes out. This is also how React works. It's a huge part of why React is as good as it is, because you don't have to think about what is the state of the onboarding controller when the database comes in. What's the data being stored in user management service by the time onboarding controller is triggering the update? It's so much cleaner. And the industry is moving this way. React's a huge part of it. The general push back on MVC, which, believe it or not, I think Bob and I are pretty aligned on, that our applications shouldn't be broken up arbitrarily into model, view, and controller. They should be broken up by the features and the routes and the things users actually do. We're very aligned in that regard. But the cleanliness of the input and output, something I care a lot more about. And the database isn't the center of the universe, but it is the input point. And data isn't entered into my service by going into a function. The data is entered into my service either by being in the database when the function's called, or by calling a function that does nothing but update the database and then trigger an updated state. A controller has state. Controllers have their own state in it. So we would be creating a new controller here. If instead of onboarding controller, this was do onboarding flow. If instead of a controller, you thought of this as a function that takes an input and a new output comes out. Very different from a controller going to database, getting some information, passing it through a model to a view that then allows for the state to be updated in the UI. I like this framing. It's OOP versus functional applied to architectures. Yes. Yeah. The big difference is that none of these pieces own the state. The user management service isn't really a service. It's a set of functions that you can call that will update the database. The billing service controller is more like on checkout. And this takes the inputs from the user triggering checkout, changes the shape or does whatever to it, and then passes it to update user state. And now none of these things have state of their own in them. All of these things are just the logic part. That is good. The logic is taking some data input, updating other pieces of data in the database, and a clean output comes out. There can still absolutely be bugs. There will still absolutely be bugs if you build this way. The difference is it's much easier to find them. If you build like this, and you have a weird bug where the user management service is incorrectly persisting old user data when new user data comes in, because it's not coming from the database with a pure functional call, it's its own stateful entity. Figuring out that that happened there is way harder if that's abstracted into its own thing. I'll just write the mock code. So you can think of this as like an endpoint that gets hit when a user completes checkout. Has checkout info, we get the user ID, we get the user from database. If there's no user, throw error. Checkout valid, await validate checkout. If the checkout's not valid, throw an error. Await update user, user ID, credits, send the checkout email, and then trigger a refresh or whatever. This is the way I'm describing to do this. And then on the other end, you have like export, async, function, render, homepage. We'll pretend we've already somehow passed user ID here and validate it too. Even doing that yourself isn't too hard. You grab it from cookies or whatnot. But here we have, if no user, throw new error, const credits, user credits, return, div, credits, whatever. You get the idea. This is very different from how you would do this in an OOP, very like clean codey way. I hate writing code like this, so we're going to ask a bro to do it for us. Rewrite this code to showcase best practices in an OOP clean code way. Hopefully you can already see the problem. Class checkout service, private user repository, private checkout validator, private email service. You have to construct all of this. You have to create these public-facing functions and then call them when you actually want to do it. I think they had this, the commented out code here is what this would look like to use. The user repository is a object, database user repo. Checkout validator is an object, simple checkout validator. Email service is an object, new SES email service. Checkout service is an object, checkout service. All of these have their own state that can be in any state at any given time. So when the checkout request function gets called, we call checkout service.processCheckout with the checkout info. We don't know what state this is in. We don't know if this already ran, and if it did, what it ran with. We don't know what the current state is inside of it right now. Like, does it still have a user repository? Is it for this user? Is it for a different user? Checkout validator, like these can all be in their own different states in there, and that detail, it's obfuscated from us as we develop. We have to go find this process checkout function, which doesn't tell us the order things ran in at all. We don't know just from reading here when the constructor was called, what it was called with, what the order of events is at all. We have to stare at this function, think deeply about our system, and guess whether or not the bug happened here. It's not good. It just isn't. And there's a lot of great videos breaking down why like OOP patterns for application design in particular are not great, because applications in many ways are inherently ephemeral. The server code might be running for a long time, but a user's given session with that service isn't something that should be treated with all of these stateful objects throughout. Every additional instance of state is an additional surface area for bugs, and the more you can reduce it, so you start with state, like checkout info, and what comes out is a database transaction, or the other way, where you fetch data from database, you fetch values as well, and then you render the result. This is the much easier way to identify bugs as they happen. This code is perhaps less clean, and I'll admit, certainly harder to test. But this code is so much easier to debug when things go wrong. Someone said React components are nested too, and they have their own state. Yes, but they are top to bottom. And the state the component has, it has to either come from the application running or from the parent. And when a parent changes some value, that value will go all the way through the tree. That's part of the beauty of what React does, is a state change triggers everything down the chain updating, which makes it way easier to debug going the other direction. I'll admit that games, which are long-living processes with a lot of complex stateful objects with weird interactions, OOP is really good for games, a lot of them at least. It's not good for applications where you're rendering a page, because the state only needs to exist from when I hit refresh to when the content appears. Otherwise, it is persisted. And the more you can turn your applications into a pipe that turns data in the database into UI for the user, the easier it is to maintain, debug, and iterate on going forward. And that's why I think convex is really cool, because it reduces the gap between the client state and the server's understanding of it in the database. It makes it less likely the client and the server are ever out of sync. And those out of sync moments are the root of so many issues in application design. It's also the problem with this massive pile of services, is what happens if user repository is in a slightly different state than we expect in the checkout validator. If these things all have their own states, they can fall out of sync. And if they fall out of sync, life gets way harder than it needs to be. Our job shouldn't be making sure all the states are perfect between these things. Our job should be building pipes to turn data into experiences for users. One last piece I want to touch on, which was the convex thing. Doesn't using the convex APIs to query and manage the data fit precisely with what Uncle Bob wants? You as the user have no idea how they store and retrieve data. Isn't that ideal? Because that's what he's going for with this type of thing. We don't know when we call checkout service.process checkout what's going on here. That's the cleanliness of it. We don't have to care about the implementation details of checkout service when we call this. But we do have to care when there's a bug, and that's where that falls apart. One of the things I love about convex is we don't have to care too much about those details because we're treating it as just data, so to speak. But the reason that works is convex doesn't have functionality. They don't have a thing that's like convex.update user info. I have to write the logic myself, and I can command click and see it. And all of the logic has to be one shot, top to bottom, right there. We don't have stateful entities that live within convex with functions and data. And more importantly, in terms of what Bob was asking for here, we do not have direct access to the database because convex built its own abstraction in Rust on top of MySQL. He wants those two layers gone. He wants the Rust abstraction and the MySQL gone. And instead we have a layer where we call the database directly. So we can build our own database service in our application code. I don't think that makes sense. He wants to go deeper and have us build an abstraction where SQL currently is. I want to go up higher. So we have an abstraction above SQL that is easier for us to reason about in our application design. That's the difference in our takes. But in the end, we do come to a very similar conclusion. I fully agree with Bob on this one major point. We shouldn't be writing SQL in our application code directly. We should not be doing this. It's fun for demos. It's fun for explaining things. It's fun for one-off shit. We should not be writing SQL in our application code directly. I am thankful for Bob for giving me the opportunity to explain in depth why I think this. Even if we fully disagree on the reasons why and the implementation details as to how we get there, I agree SQL is the wrong abstraction. It does not understand our needs as developers of applications, but the database should be the source of truth where it makes sense to. We should reduce the amount of state in our applications to the best of our ability. And we should try to make everything that can be a simple pipe from input to experience be that way where we can. You don't need to take my word for it. There's a lot of other much smarter engineers that have all coalesced to this shared vision of building simple pipes to go from data to experience. And I don't think clean code fits there. Even if, as a result, we have the same enemies, I don't think we're aligned. And some of the things said here are a little bit absurd too. Like, ORM's bad, everything should be an abstraction, databases shouldn't lead the way we design our apps. Like, I disagree with the majority of those points, even if we have a core agreement that SQL's the wrong thing to write in our application code. Thank you all, as always, for coming through. Hopefully you learned something about SQL in our applications. And if you didn't, hopefully you at least had a good time watching. Let me know what you think. Until next time, keep your code clean.